This third video for section 10.3, we're looking at verifying our identities. And in my opinion, the verifying is a lot easier than the simplifying because the verifying actually gives you an answer, where the simplifying, you gotta just keep simplifying until you think that it is as simplified as possible. So to me, the verifying is a lot easier. So what'll happen is they'll give you an equation. They'll say that this trig identity equals another trig identity, or this trig expression equals another trig expression, and you have to get it so that one side of the expression looks like the other side of the expression. So when doing this, we're only going to work with one side, and that is the key here, that it's got to be that you work with one side. You never cross anything over the equal sign when verifying identities. You pick one side to work with and you stick with that side until like the second bullet says, use the algebra and the trigonometric properties to manipulate that one side that you picked until it is identical to the other side. So you're picking one side, taking your identities and simplifying it until you get what is on the other side. So never ever cross anything across the equal sign. So let's look at an example where we have to verify. So this is an example of learning target 10.3c, and they want us to verify that the secant of theta minus the cosine of theta is equal to the sine of theta times the tangent of theta. Now, like I said on the previous slide, you only pick one side to work with. So typically what we do is we pick the more complicated side, or the side that looks like maybe we have more to do. So I'm going to go ahead and pick the left side, the secant of theta minus the cosine of theta, just because I know that there's a possibility that I can change things into sines and cosines. There's also a possibility that once I do that, then I'm going to have a fraction, and that I can do some common denominators and combine my fraction to get one term, since that's what the right side has, is only one term. So I've got to get away from a two-term back to a one-term. So that's why I picked the left side on this one, because to me that's a little more complicated. It also gives me a place that I think I can start at. So I'm going to take and change the secant then. Secant, remember, is the same thing as 1 over cosine. So I'm going to put in 1 over the cosine, and now it's minus the cosine. So like we did in the other problem, I'm going to put it over 1. And now that they're fractions, I have to make a common denominator. So I'm going to multiply both the top and the bottom by the cosine so that I get the same denominator. And when I do that, I get then 1 minus the cosine squared of theta on top, because that second fraction will give me cosine squared of theta over the cosine of theta. Let me write that out for you so that you can see that. So I have cosine of theta minus the cosine squared of theta over the cosine of theta. Now, since they have common denominators, I can go ahead and put them together and subtract the numerators. So 1 minus the cosine squared of theta over that common denominator of cosine of theta. Then, I'm going to just pull this up here where I got more room. 1 minus the cosine looks very similar to the Pythagorean identity. So I know that my Pythagorean identity is that the sine squared of theta plus the cosine squared of theta is equal to 1. So if I rearrange that, I get that the sine squared of theta is equal to 1 minus the cosine squared of theta. So there's my 1 minus the cosine, and it's equal to the sine squared of theta. So that is what I'm going to plug into my equation. So on top now, I have the sine squared of theta over the cosine of theta. And then because I know that I have that, I'm looking to get, remember, the sine times the tangent. So I'm going to separate this out, and I'm going to think of it as the sine of theta times the sine of theta on top over the cosine. And then I can separate it out even further to the sine of theta times the sine of theta over the cosine of theta, because the first sign is like over 1. So if I were to go back up then and multiply the numerators, I would get the same thing. So then that leaves me first with the sine of theta, and then my trig identity of sine over cosine is tangent. So remember, that is one of the identities that I gave you yesterday, or sorry, in the first video. So tangent, remember, is equal to the sine over the cosine. So that's where that tangent came from. So now I end up getting So this here is the same thing as what they wanted me to get up here so that I know that I am done. Now remember, it may take you the same number of steps it took me. It may take you more. It may take you less if you did it a different way. As long as you're using trig identities to get to the other side, then you are okay. 3 minutes, so now let's look at another verify problem. So example 4, still from Learning Target 10.3c. It says to verify the identity, sine of theta times the quantity of tangent of theta plus cotangent of theta, and that has to equal the secant of theta. So now looking at it again, I'm going to pick the more complicated side. So again, obviously this is the left side, so the tangent of theta, the sine of theta times the tangent of theta plus the cotangent of theta. Since the right side is just one trig identity, the left side obviously is going to be our more complicated side. Then what I'm going to do is I'm going to distribute my sine. So the sine of theta times the tangent of theta plus the sine of theta times the cotangent of theta. And then I'm going to switch everything into sines and cosines. So the sine of theta, tangent, remember from earlier, is sine over cosine, so it becomes the sine of theta over the cosine of theta, plus sine of theta times cotangent is the cosine of theta over the sine of theta. So I'm just plugging in those identities. I'm going to go ahead and put the sines over 1. My second term, I've got a sine of theta, and then what I changed from the cotangent, the sine is on the bottom, so that actually cancels. So my sines are now gone there. And the first one, I'm going to go ahead and multiply straight across, so I get sine squared of theta over the cosine of theta. And now I have plus the cosine of theta. I'm going to put it over 1 so that it is a fraction. Now I'm going to make a common denominator so I can put them together. And so that means I'm going to multiply both the top and the bottom by the cosine of theta. And when I do that, my first one will stay the same. So the first one stays the sine squared of theta over the cosine of theta. And I'm going to add to it the cosine squared of theta over the cosine of theta. Now that they have a common denominator, go ahead and bring it up here, I can add them together. So on top, I have the sine squared of theta plus the cosine squared of theta all over the cosine of theta. And now if we remember from our identity sheet that we have a Pythagorean identity that says the sine squared of theta plus the cosine squared of theta is 1. So I'm going to replace that entire top with 1 because that's what my identity says. So it's just now 1 over the cosine of theta. And then from my reciprocal identity, I know that 1 over the cosine of theta is the same thing as the secant of theta. And that is then, what I was looking for, since this here matches with this here, I know that I am done. So again, once you get to that other side, then you can stop. But it's not as important to figure out what the answer is, since the problem's telling you what the answer is. It's the steps that you're taking and that you're using the identities in the right way to get to that other side of the equation. Let's look at another example. This is still of Learning Target 10.3c. We want to verify the secant of x plus the tangent of x equals the cosine of x over 1 minus the sine of x. So now here, it's kind of a toss-up on to what side is the more complicated side, because the one side you've got secants and tangents that you could switch into sines and cosines. The other side you have a fraction, so then you can do stuff with a fraction like multiplying by the conjugate. So I think I'm going to, though, still stick with the left side here. But again, know that you can work with the right side if you feel that that is the more complicated side. So I'm going to just rewrite that left side, so the secant of x plus the tangent of x. And like I mentioned earlier, I'm going to go ahead and switch those into sines and cosines. So the secant I know is 1 over the cosine of x, plus the tangent is the sine of x over the cosine of x. So now they do have common denominators, so I'm going to go ahead and add those together. So I get 1 plus the sine of x over the cosine of x. So So now my goal is to kind of get almost the reciprocal of this, with the exception that I need that minus sign. So I'm going to go ahead. The only other thing I can think of doing is multiplying by the conjugate. Now in order to multiply by a conjugate, you have to have two terms. Well, in this case, that would be my numerator. So I'm going to take that numerator times 1 minus the sine of x. But then whatever I do to the top, I also have to do the bottom. So I'm going to multiply the bottom by 1 minus the sine of x also. So when I do that, I FOIL out the top, and I get 1 minus the sine squared of x. Because when I do my FOIL, I get my first terms would be 1. Outside would be a negative sine of x. Inside would be a positive sine of x. So those two end up canceling. And then the last terms would be the sine of x times the negative sine of x, giving me the negative sine squared of x. And then over, and I'm just going to leave this. I'm not going to distribute it out or anything, because there's a chance that I might be able to cancel something later. So on the bottom, I have the cosine of x times 1 minus the sine of x. So now looking at that top has something to do with our Pythagorean identity. So remember, our Pythagorean identity is the sine squared of x plus the cosine squared of x equals 1. So then if I subtract over the sine, I get the sine squared. I get the cosine squared of x equals 1 minus the sine squared of x. So I can take then and substitute in for the top, because it's 1 minus the sine squared, I can put in cosine squared of x. And then that's over the cosine of x times 1 minus the sine of x. So that top, it's cosine squared, which is the same thing as saying the cosine of x times the cosine of x, still over the cosine of x times 1 minus the sine of x. And now I have a cosine on top and a cosine on the bottom, so those two end up canceling. So I end up then with the cosine of x over 1 minus the sine of x. And again, that is then what the right side of my equation looks like. So that means that I am done. Okay, so again, like I said earlier, you could have worked with the right side to get the left side by doing the conjugate first, and it still would have got you there, but it's up to you, whatever way you think looks easier. And with these problems, again, it's just a matter of trying. All these problems are in a little bit way a little different. So it's impossible for me to do every single type of verify problem, but it's just a matter of trying them, changing things to sines and cosines, multiplying by conjugates, getting common denominators, those types of things. Just try something, and eventually, it may take you a page to get to the right place, but at least you're trying something, and at least you're getting there. So just try something, and then I know you'll be successful.